properties and changes. Reading guide. Key concepts. Essential questions. What is a chemical property? What are some signs of chemical change? Why are chemical equations useful? What are some factors that affect the rate of chemical reactions? Vocabulary. Chemical property. Chemical change. Concentration. Inquiry. A burning issue? As this tar burns, some materials change to ashes and gases. The metal might change form or state if the fire is hot enough, but it probably won't burn. Why do fabric, leather, and paint burn? Why do many metals not burn? The properties of matter determine how matter behaves when it undergoes a change. Chemical properties. Recall that a physical property is a characteristic of matter that you can observe or measure without changing the identity of the matter. However, matter has other properties that can be observed only when the matter changes from one substance to another. A chemical property is a characteristic of matter that can be observed as it changes to a different type of matter. For example, what are some chemical properties of a piece of paper? Can you tell by just looking at it that it will burn easily? The only way to know that paper burns is to bring a flame near the paper and watch it burn. When paper burns, it changes into different types of matter. The ability of a substance to burn is a chemical property. The ability to rust is another chemical property. Comparing properties. You now have read about physical properties and chemical properties. All matter can be described using both types of properties. For example, a wood log is solid, rounded, heavy, and rough. These are physical properties that you can observe with your senses. The log also has mass, volume, and density, which are physical properties that can be measured. The ability of wood to burn is a chemical property. This property is obvious only when you burn the wood. It also will rot, another chemical property you can observe when the log decomposes, becoming other substances. When you describe matter, you consider both its physical and its chemical properties. Key concept check. What are some chemical properties of matter? Chemical changes. Recall that during a physical change, the identity of matter does not change. However, a chemical change is a change in matter in which the substances that make up the matter change into other substances with new physical and chemical properties. For example, when iron undergoes a chemical change with oxygen, rust forms. The substances that undergo a change no longer have the same properties because they no longer have the same identity. Reading check. What is the difference between a physical change and a chemical change? Signs of chemical change. How do you know when a chemical change occurs? What signs show you that new types of matter form? As shown in Figure 16, signs of chemical changes include the formation of bubbles or a change in odor, color, or energy. It is important to remember that these signs do not always mean a chemical change occurred. Think about what happens when you heat water on a stove. Bubbles form as the water boils. In this case, bubbles show that the water is changing state, which is a physical change. The evidence of chemical change shown in Figure 16 means that a chemical change might have occurred. However, the only proof of chemical change is the formation of a new substance. Key concept check. What are signs of a chemical change? Explaining chemical reactions. You might wonder why chemical changes produce new substances. Recall that particles in matter are in constant motion. As particles move, they collide with each other. If the particles collide with enough force, the bonded atoms that make up the particles can break apart. These atoms then rearrange and bond with other atoms. When atoms bond together in new combinations, new substances form. This process is called a reaction. Chemical changes often are called chemical reactions. Reading check. What does it mean to say that atoms rearrange during a chemical change? Using chemical formulas. A useful way to understand what happens during a chemical reaction is to write a chemical equation. A chemical equation shows the chemical formula of each substance in the reaction. The formulas to the left of the arrow represent the reactants. Reactants are the substances present before the reaction takes place. The formulas to the right of the arrow represent the products. Products are the new substances present after the reaction. The arrow indicates that a reaction has taken place. Key concept check. Why are chemical equations useful? Balancing chemical equations. Look at the equation in Figure 17. Notice that there is one iron, Fe, atom on the reactants side and one iron atom on the product side. This is also true for the sulfur, S atoms. Recall that during both physical and chemical changes, mass is conserved. This means that the total mass before and after a change must be equal. Therefore, in a chemical equation, the number of atoms of each element before a reaction must equal the number of atoms of each element after the reaction. This is called a balanced chemical equation, and it illustrates the conservation of mass. Figure 18 explains how to write and balance a chemical equation. When balancing an equation, you cannot change the chemical formula of any reactants or products. Changing a formula changes the identity of the substance. Instead, you can place coefficients or multipliers in front of formulas. Coefficients change the amount of the reactants and products present. For example, an H2O molecule has 2 H atoms and 1 O atom. Placing the coefficient 2 before H2O, 2H2O, means that you double the number of H atoms and O atoms present. 2 times 2 H atoms equals 4 H atoms. 2 times 1 O atom equals 2 O atoms. Note that 2H2O is still water. However, it describes 2 water particles instead of 1. The rate of chemical reactions. Recall that the particles that make up matter are constantly moving and colliding with one another. Different factors can make these particles move faster and collide harder and more frequently. These factors increase the rate of a chemical reaction, as shown in Figure 19. Number 1. A higher temperature usually increases the rate of reaction. When the temperature is higher, the particles move faster. Therefore, the particles collide with greater force and more frequently. Number 2. Concentration is the amount of substance in a certain volume. A reaction occurs faster if the concentration of at least one reactant increases. When concentration increases, there are more particles available to bump into each other and react. Number 3. Surface area also affects reaction rate if at least one reactant is a solid. If you drop a whole effervescent and acid tablet into water, the tablet reacts with the water. However, if you break the tablet into several pieces and then add them to the water, the reaction occurs more quickly. Smaller pieces have more total surface area, so more space is available for reactants to collide. Key concept check. List 3 factors that affect the rate of a chemical reaction. Chemistry. To understand chemistry, You need to understand matter. You need to know how the arrangement of atoms results in different types of matter. You also need to be able to distinguish physical properties from chemical properties and describe ways these properties can change. In later chemistry chapters and courses, you will examine each of these topics closely to gain a better understanding of matter.